In this lesson, I'm trying to teach the students the difference between what's an exact solution and what's an approximate solution. I talk about, is the radical an exact answer or is the decimal an exact answer? And a lot of times students want to pick the decimal form, but I talk about, well, what is, because they're not sure what the radical represents sometimes, but what does the decimal represent? Do you have to round off your answer if you give a decimal answer if it's an irrational number? Yes, so we're going to talk about that the radical is the exact answer because you're not having to round that answer, and the decimal is the approximate answer. If we look at square root of 4, it's a perfect square, so it's exactly equal to 2. Square root of 25 is exactly equal to 5. Square root of 36 is exactly equal to 6. And then square root of 0 is 0. We talk about square root of negative 4. I actually tell them this year that with Common Core and things, we always just say no real solution. But I want the students to know that there is a solution just in a number set that they're not familiar with yet. And so we're just going to put no real solution, even though there would be a solution in another number set. And so they're going to learn later and at the end of this year, Algebra 2. And then we're going to have square root of 32. I'm going to introduce two different methods to simplify this radical. There's one method is the perfect square method. You're looking for the largest perfect square that's a factor of that number, which would be 16. So if I break that down to 2 times 16, well, those are still underneath the radical, and square root of 16 is 4, and then you have 2 left underneath. Or you can start with any two factors that multiply to make 32. So if I start with 8 times 4 and just make that factor tree and keep simplifying, 4 times 2, 2 times 2, and this 4 breaks down into 2 times 2. Well, once you break a number down, that number no longer counts because it's being represented by two other numbers. It's still all underneath the radical though. So basically underneath the radical we have 5 2's being multiplied. And if you think about it, each pair of 2's is the same thing as square root of 4, which would be 2. And that's what we do, is we take one of those factors and bring it outside, and then that's the square root of 4 is 2. Take another pair, and you're always looking for those perfect squares or those pair of numbers where you take one factor outside. If there's not a perfect square and you just have one of those factors, that number has to stay underneath, so you're left with 4 square root of 2. So either way you get the same answer in simplified form no matter which method you use. If you take the square root of 32 on the calculator to get the approximate answer, it's an irrational number because it's a non-perfect square, and we talk about all non-perfect squares and we test them on the calculator while we're practicing and let them check out a few of them, and they'll see that they're all irrational numbers. They never repeat, they never terminate. And so square root of 32 on the calculator is approximately equal to 5.7. And then the final thing in the warm-up, I briefly introduced the square root of function, square root of x, what that looks like. Well, square root of 0 is 0, square root of 4 is 2, square root of 9 is 3. And we talk about what would the decimals look like, what would the points look like in between the numbers that are perfect squares, and it would be irrational numbers. They are still real numbers, and you could estimate where those are at on the graph, but basically the square root function is just a curve going upward and starts at 0, 0.